We want to evaluate the given triple integral over the region E, where the region E is defined here, where x is greater than or equal to 1 and less than or equal to 2, y is greater than or equal to x and less than or equal to 2x, and z is greater than or equal to 0 and less than or equal to x plus 3y. Let's begin by looking at the region of integration, the region E in space. The plane x equals 1 is graphed here in green, and the plane x equals 2 is also graphed here in green. The plane y equals x is graphed here in yellow, and the plane y equals 2x is graphed here in yellow as well. And then the plane z equals x plus 3y is graphed here in blue, and z equals 0 would be the xy plane. So the region of integration is this region in here, below this blue plane, above the xy plane. So if we look at this at a different angle, say this angle here, the region of integration, the region E, is this solid region here. Now let's set up the integral. Because we have z defined in terms of x and y defined in terms of just x, and x defined in terms of constants, we'll use the order of integration dz, dy, dx. So we'll have the given triple integral, where the integrated function is 2xz, and then for differential v, we'll use dz, dy, dx. And now for the limits of integration for z, we can see z is bounded by 0 and x plus 3y. So 0 is the lower limit of integration, and x plus 3y is the upper limit of integration for z. Now typically we would want the xy trace to help us determine the limits of integration for y and x. But in this case, because we already have y defined in terms of x and x defined in terms of constants, we really don't need the xy trace, though I did include it here on the right, where here's x equals 1, here's x equals 2, here's y equals x, and here's y equals 2x. So this region here can help us determine the limits of integration for y and x. If we go back and look at the region E in space, if we look down on the xy plane, this region here is the xy trace. Notice how this area is bounded below and above by y equals x and y equals 2x, which is the reason why the limits of integration for y are from x to 2x, which we can actually tell based upon this inequality here. And then the area is bounded from left to right by x equals 1 and x equals 2, which is why the limits of integration for x are from 1 to 2, which again we can tell from this inequality here. So now we first integrate with respect to z, treating 2x as a constant. So we'd have 2x times z squared divided by 2, if we wanted 1/2 z squared. Let's go ahead and simplify this antiderivative. Notice how the 2's are going to simplify to 1, so we have just xz squared. And now we need to find big F of b minus big F of a by performing substitution for z. And let's do this on the next slide. Now remember, we're performing substitution just for z, so we're going to have x times the quantity. When z is equal to x plus 3y, we're going to have the quantity x plus 3y squared, minus when z is 0, we just have 0 squared. So simplifying, let's go ahead and square the quantity x plus 3y. So we're going to have x times the quantity x squared plus 6xy plus 9y squared. Let's go ahead and distribute the x. So we're going to have x cubed plus 6x squared y plus 9xy squared. And now we integrate with respect to y, treating x as a constant. So we're going to have x cubed y plus 6x squared times y squared divided by 2, or 1/2 y squared. and then plus 9x times y the third divided by 3. Let's go and simplify the antiderivative. So we have x cubed y plus, here we're going to have 3x squared y squared, and then here we'll have 3xy cubed, so plus 3xy cubed. And now we need to find big F of b minus big F of a by performing substitution for y. So we first substitute 2x for y. So we'd have x cubed times 2x plus 3x squared times 2x to the second plus 3x times 2x to the third minus, now we substitute x for y, which would give us x cubed times x plus 3x squared times x to the second plus 3x times x to the third. And now simplifying, here we're going to have 2x to the fourth plus, well, 2x to the second is going to be 4x squared. 4x squared times 3x squared would be plus 12x to the fourth, plus 2x to the third is going to be 8x cubed. 8x cubed times 3x is 24x to the fourth, minus, here we'll have x to the fourth, plus 3x to the fourth, plus 3x to the fourth. Now combining like terms, notice how here we're going to have 38x to the fourth, and here we're going to have 7x to the fourth. So 38x to the fourth minus 7x to the fourth is equal to 31x to the fourth. And now we integrate with respect to x, so we're going to have 31 times x to the fifth divided by 5, or 31 fifths x to the fifth. And now evaluating here, we have 31 fifths times, when x is 2, we have 2 to the fifth, minus, when x is 1, we have 1 to the fifth. So simplifying here, we have 31 fifths times, this is going to be 32 minus 1, which is 31. So 31 fifths times 31 is equal to 961 fifths as a fraction, or as a decimal, 192.2. So this is the value of the given triple integral over the region E. I hope you found this helpful.